Hi, I'm Fernanda.
Hello, I'm Kay.
So for this week's reading response, we'll be going over key concepts and questions about steel and steel framing.
So first we'll be starting off with steel. There are many things that make steel a very reliable and strong type of construction. So using this type 2 construction type allows you many of these benefits, such as off-site production, rapid assembly on site, precision and predictability of using these steel members, and how steel is isotropic, which means that its properties are working the same way in all directions. Compare that to wood that is anisotropic, that acts differently in many directions because of its grain. So by understanding the properties of different shapes, you can really play around with the aesthetics of steel. Okay, in this diagram, these are variations of standard structural steel shapes used in construction. And the diagrams illustrate different weights of the same section. The wider solid shapes are called plate or sheet, and then depending on their thickness in relation of their width. What type of shape is usually used in steel construction? So the W shape, because the other shape, the S shape, went out of fashion. So the W shape is most used in contemporary construction now. Okay, now let's have a more comprehensive look at the W shape. It is also considered the wide flange shape beam with the identification of W10x39. The first part means the amount of inches in depth, which is 10 inches deep. And then the second number is about the amount of pounds per foot that it can support. So it's 39 pounds that it can support. And if the section of the shape gets bigger, most of the weight is added onto the materials of the flanges. So the web is staying relatively thin. And this is just a visual connection of the intersection of these structural members with the arrow pointing towards the plate. This is just another image of what the plate would look like when it's bolted down. Now, steel has qualities of strength, stiffness, and fire resistance depending the materials used to increase its fire ratings. So in terms of strength, steel has a whopping 29,000 KSI. And KSI means kip per square inch, and kip is basically just the 1,000 pounds that it can support. So it's very strong in proportion to its weight. And steel is also ductile, which means that it actually gets stronger when it kind of breaks. So it doesn't really break, so yeah, it rather gets stronger when it tries to break. So it's not brittle unless exposed to cracks or sharp turns or very harsh temperatures.
So now that we've taken a look at some of the pieces, let's talk about how they go together. Here's the question: how can steel shapes be joined? There are three methods, which are riveting, bolting, and welding. The riveting has been replaced with less labor-intensive techniques, which I'll talk about. Great, so now that we've taken a look at the different pieces, let's talk about how we can join them. So the three types of joining are riveting, bolting, and welding. And riveting has been replaced by less labor-intensive techniques, which I will be talking about. So here's bolting. It is typically done with high-strength bolts and a pneumatic impact wrench, which you can actually see in this diagram. And this allows a visual verification of adequate bolt tensioning, which is actually a time saver during inspections, and it can be installed by one worker. Now, welding, there are connections that can actually be stronger than the members they join, which is intense, and they merge the members as if they were one piece. It's done using an electrode. It is a metal piece that is held close to the seam that is going to be welded, and the heat melts the electrode and the seam, combining them into one. So here's an example of different types of welding that they can take place. Now, which joining method is best to be used on site? And that would be bolting, because it is quick and easy, whereas welding requires additional gear, so there are protective screens for the sparks that come from the welding, and etc. Now, going back to the example that Kay actually brought up, here we can see an example of a bolting in which this angle piece is being bolted to the web of the beam and the flange of this column. Similarly, this could have been accomplished by welding this piece to one side at the shop and then just bolting to the flange on site. So there's two ways that you could have gone about doing this. Now on to our architectural example. We're going to be talking about the Amazon spheres, which are located in Seattle, and they were designed by NBBJ, and it's a trio of glass spheres which are a multi-level botanical garden. And they worked with the structural engineers at Magnusson Clemensic Associates. So it's 180 alligated pentagonal modules made with steel frames. And these two pictures I actually took myself when I visited the site, which is really cool. And for lateral stability, this building actually has a concrete core, which is one of the three types of lateral stability we've talked about. Just to review them, they are shear walls, like the concrete in this case, the brace framing, which uses diagonals and triangulation, and rigid connections. And this is just an interior render, which kind of shows the structure a little bit better than the images I was able to get.